pool scenario database and what we consider as the cornerstone for connected and autonomous vehicle safety assurance process. So we're going to talk a bit about the motivation for doing this. We'll introduce a concept of informed safety, which is essential for our safety assurance concept for autonomous vehicles. We'll talk a bit about operational design domain and the work that is done around it and the work that we personally have done at Warwick and Deepen. And then we'll introduce the safety pool scenario database and then finish off with a summary. Because we, on our side, we are engineers, we tend to like numbers and talk numbers. So I wanted to start off with giving you a few numbers. Some of you might be familiar with some of these numbers. The 11 billion mile challenge problem, which suggests that we need to drive these connected and autonomous vehicles for 11 billion miles to prove that they're even 20% better than human drivers, which all of us on this call would appreciate is not going to happen. It's not a reasonable thing to do. However, the second number here is a much less appreciated number, which suggests that even if we could introduce autonomous vehicles, which are 10% better than human-driven cars, in the next 30 years, we can still save around 100,000 lives. Now, that's a big, big motivation to bring some level of autonomy in the human driving side of things. However, we are absolutely of the opinion that we will not be able to prove that autonomous vehicles are 100% safe. So,
Siddartha, can I say one thing? I'll say that the conversation will be open for questions. So if someone wants to jump in, please do. And Yaakov Shem Tov, I think that the first number that Siddartha mentioned, because the Ministry of Transportation, Dedi and Yaakov, they were struggling with thinking maybe there is some kind of formula to show that, you know, something like in the plane industry or in the aviation industry to show that autonomous vehicles are safe. And you're saying that we need 11 billion miles to demonstrate that AVs are only 20% better than human drivers. So I think it gives us a clue about the possibility of such a calculation for the moment, for the time being, which is just not possible.
Yes, absolutely. And if you wait a couple of slides, we'll actually make a claim that you cannot prove autonomous vehicles are 100% safe. But before I get to that, there's another very, very interesting piece. As another piece of research, which suggests that even if you give autonomous vehicles or advanced driver assistance systems to people, over 50% of the time, they will not use it. And that is a big indication for us to focus our research on. Hello? Is there a question?
I think Etty is not on mute, so I'm going to put you on mute.
Okay.
Okay, go on. Yeah.
Okay. So this is another very important number, which tells us that we need to focus our research in two parallel streams, and we need to focus our policy on two parallel streams. So if we introduce connected and autonomous vehicles and people don't use them, then there is no point actually introduce this technology. So while we are trying to make autonomous vehicles safe, at the same time, we need to ensure that they are also desirable and acceptable by human drivers. Otherwise, we will not reap any benefits. So that led us to question, how do we go about establishing safety? And which in order to answer that question, we did a very large semi-structured interview study where we were interviewing verification and validation experts from across the industry in US, in Sweden, in Germany, in India, UK, Japan, and across the automotive supply chain to understand what is different for testing autonomous systems or advanced driver assistance systems as compared to normal automotive systems. And what we found was fairly interesting, but very subtle at the same time. We found that for ADAS and automatic driving, we need to test how a system fails as compared to how a system works. This is a very important and a subtle difference, and that led us to propose a concept of hazard-based testing, where we are identifying hazards, we are identifying failures. We're not interested in proving how the system works. We are interested in proving how a system fails. And with that concept, the other thing that also came out is this concept of absolute safety is actually a myth. So when we are talking about trying to establish autonomous vehicles are safe or automated vehicles are safe, we cannot prove that they're absolutely safe. Having said that, we can still safely use these automated driving systems as long as we are able to communicate the true capabilities of these systems and also communicate the true limitations of this system. So the key thing over here is trying to establish the true limitations of these systems so that we can communicate that to the drivers in order to ensure appropriate use of these systems, higher trust and acceptability of these systems. So this is the key concept that drives all the work right now we are doing at various regulatory forums. And this concept is, we coined the term informed safety, which is about understanding the true capabilities and limitations of these systems, of these automated driving systems. Now, when you try and divide this concept into sub aspects, there are essentially three things that we need to do in order to understand true capabilities and limitations. The first thing we need to do is understand where the system operates, where the automated driving system operates. Second, how does the automated driving system operate? And third, what claims and what evidence do we have for this claim for what we are saying about where it operates and how it operates? So in a more technical term, what we are saying is we are defining the operating conditions, we are defining the performance requirements, and we are identifying the verification and validation evidence. In other words, the operating condition itself is what we call as the operational design domain. So as you will see here, the ODD is fundamental to establishing true capabilities and limitations and establishing the state of informed safety. So why is ODD so important? So we've already established that we cannot drive 11 billion miles. So that is not even a useful method. However, you can also, a lot of industry is right now saying that let's go and do scenario-based testing and we will establish our system is safe. However, that is also a flawed concept, and it's a much less appreciated flawed concept because the scenarios that you experience in Phoenix, Arizona will be very different from the scenarios that you experience in central London. So your scenarios that you use for your testing also need to be a function of your operational design domain. At the same time, if you take two very, very similar systems, so here there are two low-speed automated driving systems manufactured by the same manufacturer in the UK. One is operating on the city roads, urban city roads, and the other is on the air side of an airport. Again, the operational design domain of these two systems is very different. Hence, the scenarios it will experience are very different. So again, the scenarios that we use for testing need to be a function of the operational design domain. It is not enough to say we'll do scenario-based testing. It needs to be a function of the ODD itself. Now, if you think of a scenario database, a very large scenario database, it will have thousands and thousands of scenarios. in order to ensure that there's an efficient way of identifying scenarios from that database, again, they need to be mapped to the ODD of the system itself. So here we've provided you with 3 different examples. One is a city center. The other one is a motorway. And this is more of an undivided IC area. Now, what we could do is classify this use cases as per their operational design domain using a taxonomy. And we'll come to that taxonomy in a minute, but let's assume we've got a standard set of labels in the taxonomy. Let's say this use case has labels like it can have pedestrians, cyclists, passenger cars, and it's got a shared pathway. So using these ODD labels, I can actually query this scenario database, which has got thousands of scenarios, to identify only those scenarios that are relevant for my automated driving system. So that if you are able to map everything to the ODD, it becomes a very efficient way of not only querying the database, but also going about your CAV assurance process. So taking the next step in terms of why is ODD so important, we've talked a lot about the ODD location itself and the ODD taxonomy. Having said that, once you've defined your ODD, the next step that you do is you define the desired behavior of your automated driving systems. Now, you can have a behavior library of your own, or you could use behavior libraries that have been generated by different organizations across the world, like Singapore, like NHTSA in the US, like Waymo. We've also generated one at Warwick. And if you add the ODD onto the behavior, what you get is a qualitative scenario. Now, you could go from a qualitative scenario to a logical scenario, then to a concrete scenario. Essentially, this whole section are different abstractions of scenario, which will be present in a scenario library. So there's a lot of talk about this in the industry and the research community. Where we are missing the trick right now is how do we go about making a case for completeness, or how do we go about making a case for a metric? Now, this framework was created as part of the Safe Drive initiative by the World Economic Forum. And we've identified a process of going from ODD to scenarios. We'll talk a bit today about how do we go about doing this concept of completeness. But before we do that, let's just refresh ourselves in terms of what is an ODD. So as part of the international standards, which we are very fortunate that I serve as the work item leader for, and I was also the technical author of the British standard that defined a taxonomy for defining an operational design domain. So we've got 3 different buckets under which we define an ODD. We've got scenery, which is everything that is geostationary in your environment. Things like junctions, things like road structures, things like traffic lights. Then we've got environment, which talks about the weather and the illumination, particulates, and connectivity around your automated driving system. And lastly, we've got dynamic elements, which talks about the traffic and the type of traffic that you have around you. For example, you might have pedestrians, but you may not have high-speed motor vehicles. So these are the 3 attributes under which we define our operational design domain.
Siddartha, can I ask a question?
Sure.
So we have our Ministry of Transportation and the Ministry of Justice, and everyone who is here on this call, we are part of a committee that's creating recommendations for a regulatory framework for the operation and trials of autonomous vehicles. And the first trial or the first pilot that we're going to have, which won't have a driver behind the wheel, will be the Mobileye pilot that is supposed to happen in 2022. And I think that here you're giving us just a framework of thinking what is the ODD that the Mobileye vehicles are going to operate in, and through that ODD to define the driving scenarios, which will be different for every ODD, if I understood
exactly.
correctly. So, for example, the vehicles of Mobileye, they're going to go in Tel Aviv. So we have a lot of micro-mobility. We have a lot of people that are walking in the street. We have a lot of traffic. So it will necessarily change the scenarios that we are collecting, because Yaakov or Daddy, if you're here, and if you would like to relate, maybe you can say a few words if you took in consideration when you thought about the 60 driving scenarios, if you took in consideration the ODDs where the vehicles of Mobileye are going to operate in.
Yeah, so I will try to answer this question. Basically, when we build this 60 scenarios, we haven't still considered the ODD of the system, because now we are trying to build like an archive of scenarios, which we will have to choose later on when the companies will ask us to get the approval for the system to go on public roads. Then we will choose the scenarios to test the systems according to the ODD. But now we are trying to look at those scenarios as a more general perspective.
Okay, actually that is very similar, Jakob, to our approach also. What we do is we've got a hybrid approach to scenario generation, and we'll come to that a bit later in the presentation, where we create the scenarios as a part of the system. But when we talk about the safety assurance part of the automated driving systems, we overlay the ODD on top of these scenarios. So I think we've got a fairly similar approach in that sense.
Okay.
Okay, Maya, do you have another question, or shall I continue?
No, you can continue. If someone else have a question, then you can jump in. If not, you can continue, Siddartha. Thanks.
Okay. So we are using this international standard for defining the operational design domain. And just before we go into a bit more detail, I just wanted to bring all of us on the same page in terms of what is a scenario and what is an ODD, and the difference between the two, because that would be crucial in the next slides that we have. So if you talk about a simple case where we are trying to operate on a T-junction like this, so the ODD definition of this particular situation could be that I have a divided single lane T-junction. So that is my ODD definition. Or I could also say my ODD definition is a divided single lane T-junction, and I can also operate under traffic around me like passenger cars. So passenger cars, divided single lane T-junction is my ODD definition. However, as soon as you put behavior around these actors, like V3, you've seen a behavior over here, V1 is turning right, the ego vehicle is turning left, that's when it becomes a scenario. So this definition over here is what is a part of a scenario definition. So as long as there is no behavior, that is your operational design domain. As soon as you put behavior on top of those actors, that becomes your test scenario. So here we're talking things like drive towards, turn right, drive away. These are the behavior definitions as part of these scenario. So that's our working principle over here. Now, the question is, most of the time, when we talk about ODDs, we tend to focus them on scenario generation, or we focus them on operating conditions, or we focus them on behavior competencies. So these three tend to be the most usual cases and most usual users of an operational design domain. But the less appreciated, and actually what I would say as more important uses of an operational design domain, is the relation it has to scenario completeness, safety metrics, and simulation requirements. And we're going to talk today a bit about scenario completeness and safety metrics. Simulation requirements is a concept in its own, and we can, if that's of interest, we can have a separate discussion. But I'm going to talk today about these two aspects. So let's, just bringing you back to the earlier slide that we had, that we're talking about, you go from an ODD definition, you add your behavior, you get your scenarios. So now we've got the scenarios. How do we claim completeness? And here we've got a new concept that we have introduced as part of this CAV safety assurance process. And this is something that we are discussing with regulators in Canada, in the UK, with the European Commission, and also with people in the US. And it's a concept of an ODD-based digital highway code. In the UK, we've got a set of highway code rules that are the driving rules for all human drivers. So all human drivers are supposed to adhere to these driving rules. Now, if you look at any of these driving rules, essentially every rule is defining doing some behavior somewhere or not doing some behavior somewhere. So every rule, we've got 306 rules in the UK's highway code. Every rule in those 306 rules can be classified into either of these two categories, either doing something somewhere or not doing something somewhere. Now, if you take a step back and you look at it, that doing something or not doing something essentially is the behavior competency of the automated driving system or of the driver. And the somewhere is actually an ODD instantiation or an aspect of an ODD. Now, let's take an example from a real world highway code rule in the UK. Now, this is the UK's Rule 185 from the highway code. So this is about how do you maneuver around a roundabout when you are approaching a roundabout. So this text on the left is word to word copied from the highway code rule. So it talks about when reaching the roundabout, you should do XYZ. So if you look at it closely, each of these sentences is a combination of a behavior definition and an ODD definition. So for example, I'm saying when reaching is behavior, the roundabout is an ODD. Give priority to traffic is behavior. Road markings or traffic lights is an ODD attribute. So every rule here is a combination of either behavior or ODD. Now, why are we doing this? The reason we are doing this is we can now codify these rules using ODD and behavior concepts and a semi-formal notation to write these rules. And what that would give us, sorry, there's a question? Okay, what that would give us is from a government or a regulatory user journey, you could think of, let's say a manufacturer comes to you today and says, I've got these ODD attributes and I've got these behavior competencies, or this is my desired behavior. So they will always give you these two as an input to the assurance or regulatory or as approval process. What you could now do is identify via the safety pool scenario database all the scenarios that are relevant for your particular ODD and your particular behavior competency that have been provided to you by the manufacturer. However, the more important bit over here is, now that you've got the ODD and the behavior, you can also identify all the digital highway code rules that the automated driving system will need to be compliant with, because our digital highway code rules are also a function of the ODD or the behavior. So now what we've got is, given the ODD and the behavior definition by the manufacturer, using the database, you can get all the scenarios that it needs to cater to, and you can get all the relevant rules that it needs to be compliant with. So at an initial level, you've got a level of completeness by saying, if my automated driving system can handle all the scenarios for that ODD and at the same time be compliant with all the digital highway code rules for that ODD and that behavior, I can have a level of confidence that this automated driving system is safe, and I can approve that. So this is a regulatory and government user journey that we are in discussions with various stakeholders internationally, and it seems to be being taken on board by various governments internationally right now. Any questions around this concept?
Well, you probably understood already that we are using the same concept. We have developed scenarios. We are looking into the ODD, etc. Well, the question is, how can we check, or is it feasible to develop an instrument like well, let's say an instrument to check in order to be confident that the car is safe. And this is actually the question: what kind of tool we can use or develop for that?
And exactly, Yaakov, for that particular reason itself, we've created this concept of a ODD-based digital highway code, which would, when you supplement this with your approach for ODDs and scenarios, you can actually make a claim that it is at least as safe as the human driver.
Well, we are thinking about developing a simulator.
So I will come to that. So these are only a set of scenarios and the corresponding rules that the system will need to be able to comply with. Now, the way you check that would be in simulation.
Okay, go ahead. If you're going to speak about the simulation, so go ahead. No
yeah. Okay. So
now I had another question about the digital highway code. So when you're talking about like from like a legal perspective or from Ministry of Justice perspective, when you're talking about digital highway codes, does it mean to change all the 603, or I don't remember the number that you mentioned for the like traffic rules in the US, to change them and transform them into a way that will also fit digital or like autonomous driving? Or should you just like accommodate them as is to autonomous vehicles to comply with? I mean, how does that actually work?
Okay, thanks, Maya. So on this concept, we do not change the rules per se. What we do is so most of these rules are in natural English language. We convert them into a structured natural language, or a machine readable language, as whatever you may want to call it. And we give them an ODD and a behavior functionality. So we don't change the rules, we just write them in a way that they are relevant in terms of ODD and behavior, but we convert them into a structured natural language. The reason we do that is for the point that Jakob was mentioning, that we want to actually use these rules in simulation. So these rules then get transported into simulation, and in order to make that transportation in an automated manner, we need these rules in a structured natural language so that we can develop the tool chains associated for those simulation testing.
So if I understand correctly, then in the simulator, in the driving simulator that Jakob talked about, you don't only test scenarios, you also put inside traffic ordinance, which is really, really cool. I don't think we've ever heard it. You're taking all traffic, like in Israel, we call it traffic ordinance. So you're taking traffic ordinance and regulations, you're putting it into a machine understandable language, and then you're pouring the scenarios and the ordinance and regulations into this simulator, and you're checking everything as a whole. Like exactly. How does the vehicle operate in the scenario, and does it comply with the regulations while it's doing that?
Exactly.
Maya, we are already there.
Okay, I didn't know.
The simulator, the simulator that we are checking is doing exactly the things that you have mentioned. Okay. It's not only
but it's important to mention that, because there are also other people in the conversation from other divisions in the government. So just for everyone to be informed.
It's not only the scenarios that we ask them to check. They put the Israeli ordinance in it, and so we are checking it as a whole. Okay, so this is the simulator that we are checking these days.
Okay. So just moving on from that side of things. So when we talk about this whole process from scenarios all the way up to approval or certification, there are only three basic things that we would need when we are going through this approval process. You need scenarios, you need an environment like simulation, and at the end of the day, you need to make an evidence or an argument around this whole process. Do you approve or not? So if you divide that into one level down, what you're saying is you need to create scenarios, you need to format scenarios, then you will need to store scenarios, and then plan and execute your scenario in a particular test environment. And ultimately, that you will decide and analyze and decide if your system is safe or not. So a lot of this environment is where we do the simulation-based testing, based on which we will analyze and decide if the system is safe or not. Today, we are going to talk a bit more around the store aspect of this chain, which is one of the aspects in this whole pipeline that is needed from a cab assurance perspective. And that's where we introduce the safety pool scenario database, which brings together the scenarios, which brings together the rules, and brings together the simulation offering in one single package. So I'll hand over to Nico. Nico, if you would like to speak through this.
Yeah. I can present myself if you want, so you don't have to.
Okay. I will stop sharing.
Thanks, Siddartha. Okay. Do you see my screen?
Yes.
Okay, great. Okay, so as Siddartha mentioned, we just came then to the need of a scenario database to store all the different possible scenarios that can happen in specific ODDs. And today we have multiple scenario databases scattered around the world that were also the results of some government-funded projects, like Pegasus in Germany, Sakura in Japan, Streetways Netherlands, and there are many others, Qatar, China, etc. The problem with that is that each one of these databases uses different description for scenarios, collects data in a different format, in a different ways, and they don't talk to each other. And also, this fragmented landscape makes it very hard for manufacturers and AV developers to scale from one location to another and adapt each and every time to new formats and new databases. So what we're trying to do, and our goal with the Safety Pool initiative and the Safety Pool scenario database is basically to bring this under one unique roof globally and become the global basically reference scenario database for connected and autonomous vehicles and ADAS safety assessment and approval and certification worldwide. So that when we launched this initiative, Safety Pool, with World Economic Forum, WNG, DEEP, and others, we envisioned a world where every automated system can be transparently tested, validated, and certified through common processes and infrastructure that are shared across industry and other stakeholders globally. So our goal with this is to be very much of broad scope, let's say. So the platform that we just launched, the Safety Pool Scenario Database, is something that is being designed from day one with a multi-stakeholder view. So we designed this platform where not only CAF developers or tier ones and tech providers can tap into, but also government regulators and researchers. And as we'll see later, we already have done a lot of work, and we keep doing work with the UK government. We are in deep conversation with also Transport Canada, with Canada. Then we are entering this Dubai competition and help them into their autonomous vehicle challenge competition to help to frame and design an assessment process and use the Safety Pool Scenario Database as a basis to develop this certification and basically this exam for testing and deployment. And also we're keeping adding more governments basically in our discussions each and every day, I would say. So the Safety Pool Scenario Database has been the result of multiple and extensive research and interviews with a lot of stakeholders coming from the 4 groups that I mentioned. And we came out with these 6 main features that were required to fulfill all the basically requirements from the research stakeholders. One is that each and every scenario that is stored into the database, and now we have around 100,000 scenarios spanning multiple ODDs. Each and every scenario is tagged with labels, basically with tags that follows closely the ODD taxonomy that Siddartha mentioned before, and the behaviors that Siddartha also mentioned before. Then we have an interesting features that through these ODD tags and behavior tags can match the scenarios with a real world route. So with a piece, really some streets in the world where that scenario can virtually happen, because that's the ODD specifically that can fit that scenario. We'll see that in detail later. Then we designed this with a simulation platform agnostics point of view, so that each and every scenario can be played in each and every simulation platform. That exist a lot of them. So that's something we wanted to do. Then the user, regardless of being government or industry or academia, needs to be able to filter and search throughout the whole scenarios using the behaviors and the ODD tags, as we saw before, and also additional tags that cover concepts like authorship of a scenario version, or whether is it relevant for a specific function under test or other things. Fourth is that we also wanted to build something that is useful not only in terms of sharing and community, but also individually. So for each and every organization that taps into it, they can extract value just by using the platform inside of the organization on its own. That's why we also designed some efficient test management capabilities that we'll see. And last but not least, we want to encourage scenario sharing and data sharing on a global scale. So we needed something that incentivized people and organizations to share data and scenarios regardless of their size and of how many scenarios they have and of how much funding they had, etc. So we designed this tokenized scenario exchange, basically that rewards valuable contributions to the database with a sort of a token that they can organization can use to purchase other scenarios. So there's no monetary transactions involved. The currency here is really valuable data. So let's talk about the platform briefly. As I mentioned, each and every scenario is tagged. You see here the where is the okay.
We can see your mouse.
Okay, you can see the mouse. Okay, perfect. So each and every scenario is tagged along these dimensions, for example, ODD, behaviors, admin tags, and also custom tags can be added. You see here the tags for these scenarios are direction of travel, lane dimension, lane marking, etc. So that these tags are used also to retrieve search and search scenarios in the database. Let's see. The important piece is that all these tags, labels, and also the scenarios that we described are very much aligned with a lot of standardization activities. So we use tags from ASAM Open Label standard that I'm leading, and the OpenODD standard that is designing and developing a format for ODD description is being led by Siddartha. And also, we are both, Siddartha is chairing a lot of ISO committee, BSI committee, is an SAE. So we are very much involved in all the standardization efforts around these topics for AVs. And we definitely want to, our scope is definitely to encourage the adoption and make use a lot of, and make an extensive use of standards so that we enable multiple organizations, multiple stakeholders to benefit from our effort. Again, the search of the scenario is using the tags. So we can search in the big database of scenarios using tags and building also some complex queries using logical statements and also exclusion, grouping, etc. so that we can really perform an in-depth search of what scenarios we are looking for at a certain moment in time. Again, we touch on the feature that I mentioned before. So we see that we mapped some routes in the world. Now you see a piece of UK, the Midlands Future Mobility Testbed in particular. So this route here, both the blue pieces and the gray pieces have been tagged according to their ODD with the exact same tags that we use before that I mentioned, and we use also to categorize the scenarios based on an ODD. And through these tags, we can see that, for example, a specific scenario that has been selected, this feature shows us the blue pieces, which tells us this scenario can virtually happen in these segments of road, of real world route. And this is a very useful thing to say because it helps regulators, for example, to understand which are the relevant scenarios that needs to be tested for a specific piece of route in, for example, in Tel Aviv. Or, and we are not limiting ourselves to also just to real world routes, but we're also starting to mapping test tracks so that organization can say, okay, I want to see which of the scenarios that I have makes sense to play in which piece of my test track. And so it's a very efficient way to design test cases and understand how to go about or actually deciding which is my test suite that I need to cater to a specific place in the world or a specific test track. So that we bridge the gap basically between simulation and the real world testing.
Just one thing to add.
And this is another feature that, sure.
Yeah,
sure.
So one can also have, on the previous slide, one can also have a digital twin of the real route itself. So you can execute the scenario in the simulation, and you can also execute the same scenario in real world and compare the results in order to actually validate your simulation itself. Nico.
Do you have any methodology to do this?
No,
to do that?
because Sorry?
Do you have the methodology to validate the simulation results?
We are developing some. We've got initial concepts that we are in discussion at the UNEC regulatory forum. Happy to share those with you, Leon.
Okay, thanks.
Yeah. So then this is another feature that we built into our scenario database. We have this concept of test suites that is basically another way of organizing scenario libraries in subsets of scenarios that are specific for a specific test. For example, I want to have a function under test or any other way that I want to cater my scenarios and basically organize them into folders. So for example, I show you this route, I can build a test suite that makes just to test a specific system into this ODD, this very geofence and confined ODD, for example. This I can achieve through test suites. And the good thing is also that all these test suites and maps, etc., can be seamlessly accessed through our API so that organization can also immediately port a test suite into a simulation platform and run the test there with a very smooth integration, let's say. Talking about simulation platforms, we built an execution toolchain that executes all of our scenarios in Carla, which you see here. It's an open source simulator. But of course, we designed the SDL, our scenario description language, in a way that is simulator agnostic, so that with the right toolchain, it can be executed in any possible simulator. And now we are talking a little bit about these scenarios that we already have in our database. And starting from our safety pool scenario description language. So again, it's important to understand the rationale that led us to designing a new scenario description language for safety pool. Because as I mentioned, this was the result of a very extensive research process where we interviewed a lot of stakeholders, and Siddartha's group did an extensive work in that. And there was the need to fulfill competing requirements from industry and technical stakeholders that require a scenario description language which is very efficiently machine readable and not verbose and summarized and easily manipulatable on one hand, but on the other hand, we have regulatory stakeholders and non-technical stakeholders who really need a scenario description language that is very close to natural language and very easily for humans to understand. So we designed this SDL with these stakeholders in mind, and so we cater it into two levels of abstraction. The scenario description level 1 is basically a textual description very close to natural language that can be used by regulators or system engineers. While the same scenarios can be also described in SDL level 2, which is very concrete and very structured so that a machine can parse it and read it and execute in the simulator. So the SDL follows closely what we already saw, all right? The ODD and behaviors elements that we saw. So it's divided basically into 3 buckets or 3 sections. The dynamic elements piece that provides a description for the behavior of all the moving agents and objects, including road users, pedestrians, and animals, etc., and which really states the unfolding of the scenario. So with triggers, etc. So when if vehicle V1 passes the junction, then do this, while do that, etc. And this, of course, happens in a scenery, in an ODD. So we also have a section of the SDL that describes the static elements, the road structure, the fixed road elements like barriers, poles, signs, etc. And last but not least, we also needed to ingrain into the language the description of the physical conditions and the environmental conditions that make also part of the ODD definition. That being said, we have our own custom SDL for the reason that I explained to you, but as I mentioned, we are also very supportive of standards, and we are very much involved into the standardization development process. So we're already developing the converter for Open Scenario 1, which is a standard, ASIN standard for scenario description, and that is decently widely adopted, I would say. And by the end of Q2, we plan to have each and every scenario in the database accompanied or like coming out with a specific Open Scenario file attached to it. And also we are, of course, developing Open Scenario 2, which will be ready later this year, and we'll do the same for that possibly once it's ready. It's still under development as a standard. And third piece is also that some organization in the AV community, in the AV domain, they develop their own internal tool chain, full tool chain to do verification and validation. And some of them tend to use proprietary custom SDLs and description and languages. We don't want to cut them out. So we also are very happy and open to help in the development of converters that that converts to custom scenario description language and proprietary formats as well. Then we touch a piece that Siddartha was mentioning at the beginning. So where do these scenarios in our database come from? What's the origin of them? And we have mainly three sources for those. One is knowledge or expert-based generation. So experts and researchers such as Siddartha that sits down with their group and perform hazard-based testing that allows them to handcraft and design scenarios for a specific test to fail. So, for example, like the STPA analysis method that Siddartha is using, it's basically using this approach that it understands where a specific system fails and design scenarios to target that. Probably he can give more color later about this if there are many questions. The second bucket of generation is real world data logs. So there's a lot of instrumented vehicles that go around a specific place of the world, a specific ODD that collects a lot of data. We can also extract it, we can also process the data and extract the scenarios from that real world drives and port them and upload it into our scenario database. Third, last but not least, is database-driven generation. And this is also the bulk of our scenarios that we currently have in Safety Pool Scenario Database. Basically using accident databases or insurance claims databases to actually reconstruct a scenario description for those and put it into our scenario database. And that's what we did, for example, with a bunch of libraries that we have there, like Stats19, where we converted this library of accidents that happened in the UK and that led to personal injury to a full scenario description. And we have around 40,000 of those scenarios just for coming from accidents in the UK. Finally, since we want to be the reference scenario database worldwide, we need to cater a lot of use cases, and that's what and a lot of ODDs, and that's what we are already doing, and also what we are encouraging doing by incentivizing stakeholders to contribute more scenarios. So our scenarios are tackling all of these use cases from ADAS type of features like ALKS and highway driving to low speed autonomous driving, like shuttles for urban environments, to last mile deliveries or level 4 robotaxis or tracking, etc. So we want to serve all these use cases. Finally, let me briefly touch on our tokenized scenario exchange, which basically incentivize people to share more scenarios and increase the diversity also of the scenarios that we have in Safety Pool. So today we are already starting to give access to all the organizations that have requested it to the scenario database. This is happening for free, so there's no monetary transaction involved. Every organization that asked for it can join, can have access to the library. And we are starting this process in these days, and will come to everyone hopefully. But we are very glad and happy that we really had a great feedback from the AV community. So we had a lot of requests from the industry to access the database and start contributing. But basically what happened is that once people get access to the database, every organization can see around 10% of the scenario data, of the whole volume of scenarios that we have right now. So we have around 100,000 scenarios. We release 10,000 scenarios for each, basically 10%. If organizations want to access more, then they can contribute new scenarios. Once they push new scenarios in, we take them in, we ingest them, we understand if they are valid, if they are the integrity of the data is there. If that's okay, a go, then we score this contribution. So we see how similar are these scenarios to the ones that we already have into the database. Are there some interesting edge cases, something that we haven't seen yet? If the answer is yes, then the score is very high and we give a high credit to this organization. And this credit can then be used in form of tokens to just buy or get access to more scenarios that this organization still hasn't seen. In this way, basically, we grow the volume and the diversity of the database, and we give organization a reward for their valuable contribution, basically. And this is basically a system that we design in order to sustain the growth of the database, encourage diversity, and incentivize contribution from everyone. Finally, this is a very simple process that we use to get people involved. Organization can just sign up in our website. We schedule a demo, we run through the database, and then we issue access to the scenario database after some terms and conditions will be reviewed and signed. So finally, to finalize, the people behind this are mainly from deep-end perspective, me and my CEO. Then there's Siddartha and Mike, who did the heavy lifting of the world of the scenario database from WNG University of Warwick. We have David Webb, which supported us from the Center of Connected and Autonomous Labor in the UK. And also we are working very closely with Michelle and team from World Economic Forum that basically gave us a lot of help and support throughout the whole last 2 years of this project. And this was, I think, all from us. And we are both, I think, very happy to take any questions or focus then on specific pieces of this presentation.
Thanks, Nico and Siddartha. So if we'll have like maybe 10 minutes for questions, and then we'll wrap it up because we're out of our time. So yeah, someone has any questions?
I'll be happy to jump in with a short question, almost even maybe technicality. First of all, thank you very much. It was really interesting to learn and to see also how the things are developing. I wanted to say that, as Maya mentioned, we are drafting the bill right now, and while you were talking, Siddartha actually opened our definition in the Israeli bill for the ODD that we just drafted a few days ago, and added the element of dynamic elements that I wasn't aware that it's part of it today. So we already contributed to our bill. And I wanted to ask about this, about the ODD, because you were talking the whole lecture, and it was really interesting to hear how you use actually the ODD as an element to check the scenarios. While we refer to the ODD so far as a limiting kind of term, which define for the car where and how can it operate. So I'm trying to put together these two kind of reference to the term of ODD. Can we still refer to the ODD, in addition to the way that you use it as part of your language, which is, can we refer to it also as something that is kind of limiting the way, how the car operates when the car faces something that is not part of the ODD? It stops, what happens, so.
Thanks, Tamara. What you've said is absolutely spot on. And we actually have the same understanding. So ODD definition is actually a way to define the limitations and also the capabilities of the system. So that's one of the reasons I started off with saying we need to define the capabilities and limitations. The reason we use ODD as a tool for scenario definition is actually to identify and prove the boundaries of the ODD. So when you do that, it's imperative that you test at the boundaries of the ODD and test for the minimal risk maneuvers and the minimal risk condition. So that is one of the main reasons why we use ODD as a tool for scenario generation. Having said that, what we also want to do is not test a system for something it is not designed for. Having said that, I will qualify that by saying there is a set of tests that we always do, which is outside the ODD of the system itself. The reason for that is actually to prove that the automated driving system will not get activated when it is outside the ODD. So you have to do both ways in that sense. Hope that answers your question, Tamara.
Yes, yes, thanks.
Any other questions?
Yeah, from your experience, do you know if there is one of the authorities around the globe that they're looking or already using a simulator for validating the scenarios?
There is the true answer and there is the right answer for this forum. I would say almost every authority is looking at a simulation as a way of approving. However, the challenge that all these authorities are facing right now is not the scenarios, it's not the ODD, or it's not the simulation itself. It's actually to validate the simulator itself that they're using. Because, for example, if we take the example of ALKS, there are a set of scenarios that are in the regulation, UNEC regulation, and everybody knows that we need to use simulation. So it would be used, for example, the UK government will use it. It's more or less a given that we would be using it. Even any other regulator who is going to approve ALKS will use simulation. However, the piece that is missing in that jigsaw is to actually validate the simulator itself. And that's the key when that we need to answer when we go to higher levels of automation. So things like robotaxi, we absolutely will need to focus as much as on the scenario-based testing as on the validation of the simulation itself. Yaakov, does that answer your question?
Yeah. Hopefully you will be able to say that there is one authority, hopefully in few months, that is using a simulator.
Oh, okay. Okay.
Which is going to be Israel.
Yes, I guess that. I guess that.
Yeah, I have a question, please. When you define the scenarios, did you also define a success rule for each scenario? Some of the scenarios are very simple, I guess, to define the success rule. For example, the example that you showed on the side on the presentation while the AV approaches the roundabout. So basically, the success rule will be to follow the traffic rules and to act according to the traffic rules. But there are scenarios that are more complex, like, I don't know, while the AV approaches a junction and has a green light and a different vehicle from another direction suddenly jumps into the junction with the red light. And how do you define the success rules in such a scenario?
So thanks, Deddy, for the question. It's a very interesting question. whenever we define scenarios, the success rule or pass-fail criteria is defined as part of that. There are two abstractions to the pass criteria. One is at the regulatory level, like the Digital Highway Code rule that you saw. The other one is actually at the scenario level itself. So one of the methods that we use is called STPA, and we've extended that method for scenario generation. And the STPA as a method was invented at MIT, and we've extended that method for scenario generation. And as a result of that extension, it provides us with the corresponding specific success rule or pass criteria for every scenario. I can share a publication with you, which goes into detail of that concept.
Oh, okay. Thank you. It will be much helpful.
Okay.
I wanted to say that I think that from that conversation, it really shows that the Ministry of Transportation is already taking your approach in developing the driving simulator and collecting the scenarios. And we are thinking of starting a pilot together with the Safe Drive Initiative for the World Economic Forum. So I think maybe it can be interesting to partner up and see how we can collaborate further, if that's something that can be of interest for the ministry. Two ministries, Justice, Transportation, but mostly Transportation. And the second thing I wanted to ask, how is, for example, okay, now Safe Drive, like the safety pool we discussed with the government, and what are the practical steps to connect to the safety pool, or what use can governments do today with the safety pool? Like, how do you see it happening?
Nico, would you like to go first?
Yeah, sure. So, as Siddartha mentioned before, or as and myself, we are already using basically safety pool with some governments, specifically with the UK government. I think Siddartha can give more color there. But I think that also as part of our partnership with Safe Drive, what we are trying to do, what we are and our next steps are going to be, is catering these sort of pilots where Safe Drive framework happens on one hand, and on the other hand, safety pool is the scenario database that governments will use as a reference to use those scenarios to understand which scenarios to test in their specific area, in their ODD, etc. And basically, this is already can happen right now because safety pool is ready, it's launched. We have already 100,000 scenarios. We are adding more each and every day. And we'll also be happy to help there in terms of maybe if there's the need to design specific scenarios for the Tel Aviv or Israeli ODD, this is something that can be done. And also match the routes, as you saw before with that feature. We can map some routes in Israel and do the matching, understand how to basically design tests and which scenarios can be tested in that specific area. So I think that this is already something that is a concrete possibility today, and we're very much happy to scope the project according also to a specific government needs that may vary across the world. Siddartha, I don't know if you want to add something.
No, I
think just before Siddartha speaks, I want to drop something else, because we had a lot of interest, and we still have a lot of interest in the activities of the UK government. And we were in touch with Jessica from the Law Commissions. Yeah, and we really admired the work that is being done there. And it's just that we saw that currently you have the guidelines, right, that are issued by the CCAV or the CCAV. And we were wondering, how do you see, because for the moment, if I want to have a trial on autonomous vehicle, I don't need to get a permission or a permit from the UK government. So how do you see the certification process entering into force, and when is it going to happen? Because right, for the moment, you don't need to get an active permit to have a trial in the UK.
Yeah, that's right, Maya, absolutely. The reason behind that is we've got a safety driver. And because of the safety driver, the permit is not needed. However, there is a lot of work ongoing right now in terms of the steps and the permits required to remove the safety driver. And I believe the trial that you are going to do is actually removing the safety driver also. So I think that is the biggest challenge. Having a safety driver and doing trial is difficult, but it's relatively simpler than removing the safety driver completely. Having said that, we are right now also, the UK government is undertaking a project for approval of low-speed automated driving systems. So creating the framework for the approval of low-speed automated driving systems for deployment, not even removal of safety driver, but for deployment. And that's something the project would kick off in the next couple of months and due to have the framework ready by mid next year.
Thanks. Okay, so I think if anyone else have a question, then that's the time for one last question. And if not, then I really want to thank you, Nicole and Siddartha. It was really interesting and fascinating. And I do think we have a lot of ground for collaboration. So thank you so much for giving the time and the effort, and good luck.
Thank you.
Thank you.
It was a pleasure.
Thank you.
Thank you very much. Bye-bye.
Thank you.
Thank you.